Hi, 5th grade. This is Mrs. Skioka with your Flipped Math Lesson 6-2. Today's objective: I can use rounding incompatible numbers to estimate products of whole numbers and decimals. So while we're learning how to round and use compatible numbers, we're also going to use the algorithm for multiplication. And that just means like the way that you would normally write multiplication up and down with the multiplication symbol. So I'll show you that in just a minute. So for your example question says, a planner for a wedding needs to buy 16 pounds of cheese. 1 pound costs $2.15. About how much will the cheese cost? So looking at our information first, let's find out what it's asking us. First we got to find out, well, how much does the cheese cost? And it tells us that it costs $2.15 for 1 pound, and we need to buy 16 pounds. So we're going to use multiplication, because we have the same number multiplied several times. We're going to be multiplying $2.15 times 16 pounds. Okay? So today we're going to be focusing more on estimating and finding an estimated answer instead of the actual answer. So what I've done here is I've changed $2.15 to just $2. Okay? In this example. Now, if 16 is an easy number for you to multiply times 2, you can keep it 16, as you see I've done here. And if you know that 2 times 16 is 32, then you'll know that that would be about $32. Let's say 16 is not a number that you can multiply in your head, though, but 15 is. So you can change 16 to 15 and multiply it times 2, and 2 times 15 is 30. But let's say that you're not really good at your 15s. That's okay. Remember, we are just finding a number or an answer that is close. So if 16 is a number that's tricky, 15 is a number that's tricky, let's try 20. So I've got $2.15. I'm going to change that to just $2. And I'm going to take 16. I'm going to go ahead and round it all the way up to 20. Okay? And surely, I'm certain that for everybody, multiplying 20 times 2 is pretty easy for us. $40. Okay, so we know that our answer is going to be somewhere in between $30 and $40. Now, what if one of the factors is less than 1? So if it's like 0.7, 0.85, 0.2, something like that, that's less than 1, you're going to have to remember that it's less than 1. So when you multiply a number times 1, you get the same number. So if you multiply it times a factor that's less than 1, like one of these decimals, your answer is going to be less than the other factor that you're multiplying that times. You'll see what I mean in just a second. Here's an example. Manuel found that the total distance he walks to and from school is 0.75 miles. If Manuel walks 184 days, about how many miles will he walk in total? So it's asking us how many miles he'll walk in total if he walks 184 days, and every day he walks 0.75 mile. Now, let's use some rounding to find the answer. We have 184. I'm going to go ahead and just round these digits. I'm going to round it to the hundredths place here. I'm going to round it to the tenths place here. So looking at the bossy neighbor next door, I can see that that's going to change to 200, and I'm going to be multiplying it, and that number is going to change to 0.8. Okay? So here's where I'm going to show you how to use the regular algorithm. 200 times 0.8. So I've got 200, multiply it times 0.8. You multiply like normal, just ignore the decimal point. 8 times 0 is 0. 0, 8 times 2 is 16. Now, we're going to go back to that decimal point, and we see that there is one digit after the decimal point. So we're going to put one digit and then put the decimal point. Okay? So our answer is 160. Okay? 200 times 0.8 equals 160. You can also use compatible numbers if you want to. Remember, we're using any number that we can round that is going to be easy for us to multiply. So if I wanted to use compatible numbers, maybe I would change this to 180 and I'm going to multiply it times 0.7. Okay, maybe I'm really good at multiplying 7s, but I'm not so great at multiplying 8s. Then that would be a good compatible number to multiply by. So I'm going to use the algorithm, 180 times 0.7, and just do my multiplication. 7 times 0 is 0. 7 times 8 is 56. 7 times 1 is 7, plus 5 is 12. Okay, then I have one digit after the decimal point, so I have one place here I put the decimal point in there. Okay, so 126. Now you'll notice that my answer is less than the biggest factor, because this number is less than 1. Remember, 180 times 1 would equal 180, right? So since this factor is less than 1, my answer here is going to be smaller. Okay, let's give some others a try. Remember, you can estimate or use compatible numbers, whatever's going to help you find the closest answer and help you know if your answer is reasonable. Okay, so we have 0.87 times 412. I'm going to change, I'm going to round these, I think, down. So I'm going to, or round it up. I'm going to use 0.9 instead of 0.87. Got my bossy neighbor here telling that number to change to 0.9. And then I'm going to round it to the 100 spot. So my bossy neighbor is saying to multiply that times 400. So I've got 0.9 times 400. So I'm going to use the algorithm. 400 times 0.9 is, it looks like 3,600, but it's not, because I know I've got one digit after the decimal point. So I'm going to put one digit and then the decimal point. Remember, we count how many digits are after the decimal point, and then we put those numbers after the decimal point on our answer. And so our answer is close to 360. Okay. Number 2, 104 times 0.33. So I'm going to round this to the hundredths place, and I'm going to change that number to 100. I'm going to round this to the tenths place. I'm going to change that number to 0.3, and then I'm going to multiply it. Now this one is 100, so that's pretty easy to multiply. Remember what we did yesterday? If we have a number that is being multiplied by a factor of 10, count how many zeros there are, and then move that decimal point over that many places. Okay, so our number changes from 0.30 to 30. Okay, so about 30 is our answer for that one. And number 3, 9.02 times 80. So we can change that to, I think this one, I'm going to leave that at, I'll change it to the tenths place, and that's going to actually be 9.0, which is 9. And then I'm going to leave 80 as is, leave that the same, so I've got 9 times 80. I can ignore that 0, any just zeros after a decimal point I can ignore. So now I've got 9 times 80. I know that 9 times 8 is 72, and then annex the 0, so my answer is going to be 720. Okay, how about you try this one? 0.12 times 5. This time do it on your own, pause the video, and then unpause it when you're done. Okay, so you should have changed 0.12, and remember you can round it to a compatible number that's close or estimate it to a number that's close. So I'm going to round that to 0.1 times 5. Okay, and then hopefully this is something you can just do in your head, but if it helps to look at it, you can look at it like this, and 5 times 1 is 5. We have one digit that's behind the decimal point, so it's going to be 0.5. Okay, so we got about 0.5, should be right, should be definitely less than 1. And number 5, this will be our last one. 37 times 0.93. estimate that and see what kind of answer you get. All right, so I'm going to change this to 40. I'm going to round that. That bossy neighbor is going to tell it to round up to 40. I'm going to round that one, and that bossy neighbor tells me to leave it as 0.9. So now I've got 40 times 0.9. So I'm going to use my algorithm here. 9 times 0 is 0, and 9 times 4 is 36. I have one digit that's after the decimal point, so I'll put the decimal point after one digit, or right before one digit, I mean. And so my answer is going to be about 36. Okay? All right, guys, we're finished for today. That's it. Thanks so much. See you tomorrow. Don't forget to get your homework signed by your parents so that you get credit for it tomorrow. Bye-bye.